We're in section 13, and we're actually starting to get to functions. Your next test is mostly going to be about functions, but we have to do a little bit of graphing in order to talk about functions. Your graphing test is going to be the next test, so you're not going to have any graphing on this test. Like I said, you need to have a little bit of graphing to be able to talk about functions. So section 13 is a little bit of review of graphing, and then we're going to talk about circles. So first of all, we are going to be dealing with equations now with two variables. Things like, things like y equals, 2x plus 7. So it's got an x and a y. So we're not going to be solving these equations because they actually have lots of solutions. Let's look at a really simple one. Let's look at y equals x plus 7 and talk about what a solution to that equation would look like. First of all, there's two variables, so a solution to that equation is going to have two parts to it. And we usually write them in ordered pairs, the first number being the x value, the second number being the y value. And you can just see, just looking at this, if x is 0, y would be 7, right? If x is 0, y would be 7. And that is considered to be one solution. So what's another solution? How about if x is 1? If x is 1, y is 8, right? That's another solution. So that's just two solutions right there. So you can see that there would actually be an infinite number of solutions to this. And that's why we graph. Because we can't list all of the solutions, so we're going to graph them just to sort of show where the solutions lie. You know, we can't list them all, but I can show you here they are. And so that's all graphs are. Graphs are just a pictorial representation of all of the solutions for any equation. Okay, and we now don't have just a number line. We have basically two number lines here because we have two variables, 1, 2. So now we have like two number lines, and that's why we have the Cartesian coordinate system. Okay, so let's look at some of these things. Let's do some of this labeling. Let's label what's a quadrant. When we put these, when we put these axes here, notice we sort of break up the plane or the page into 4 sections. We call those quadrants. We number them. Quadrant 1 is this first one, quadrant 2, and then around counterclockwise, quadrant 3 and quadrant 4. We usually name them with Roman numerals, don't know why. Okay, origin. Origin is the point right there in the center. What are the coordinates of that point? It is 0, 0. 0 on the x-axis, 0 on the y-axis. Okay, let's label our axes. The horizontal axis, this one, is the x-axis. You probably all remember all this. And then the vertical axis is the y-axis. Okay, now what's next? Oh, we've got all the labels done. Good. Now let's plot a few points. See if you can remember how to plot points. Where is the point positive 2, comma, positive 5? So x is positive 2. So you go on the x-axis to positive 2. And y is positive 5. So we go to the y right there. So this point right here is the point 2, comma, 5. Okay, how about negative 3, comma, 5? So on the x-axis, we go to negative 3 and still go up to positive. So we end up here. So negative 3, 5 is right about there. How about negative 5, negative 6? So x is negative 5, y is negative 6. We're going to end up down here, aren't we? Let's see. There's negative 5, negative 6. And then 5, 0. So our x-coordinate is 5. Our y-coordinate is 0. So we're neither up nor down. We're right there on the x-axis. So 5, comma, 0 is right there. Okay, so that's just like a little practice to see if you remember how to plot points and different things. Let's go to the next page. Okay, we are going to be graphing some equations. And for the next test, we're actually going to get really good methods to graph equations. Pause. Okay, I'm back. Sorry about that. Don't know what happened. Okay, we're going to get really good methods to graph equations. But for now, the old-fashioned way, or the grunt work way, is using a T-chart. That's where we make an XY table. Some teachers call them XY tables. and we fill in some points. So how does this work? Well, the first point is pretty random. I mean, you pick any number you want for x. So I'm going to pick x if x is 2. And then you find the corresponding y value. How do you do that? You go back up to the original equation up here, and you put a 2 in for x, and then just work it out. So if we have a 2 in for x, y equals negative 2 times 2 plus 5. So that's negative 4 plus 5, so that's 1. So 2, 1. That means the point 2, comma 1 is on this graph. So if I plot it, it's right there. There's 2.1, 2, comma 1. Okay, so let's plot another one. Let's say I'm not going to pick a number right next to positive 2. I'm going to have a negative 2. If x is negative 2, what's y? So we go to the original equation. We put a negative 2 in place of x, and we work it out. So negative 2 times negative 2 is 4 plus 5. So 9. So we get 9. So that tells us that the point negative 2, comma 9, which is up here, is also on this graph. Now, you probably remember enough from high school to know that this graph turns out to be a straight line. That's a linear equation. And 2 points do determine uniquely a line, so we probably can guess that our graph looks like this. But I'm going to plot a third point just as a check, just to make sure I haven't made any arithmetic errors so far. So let's look at, how about if x is, I don't know, how about if x is 6? What's y? So y equals negative 2 times 6 plus 5. So that's negative 12 plus 5, so that's negative 7. So 6 comma negative 7 is a point. So 6 comma negative 7 is, whoopsie, over a little bit. 6 comma negative 7. It's down here, actually. I'm not sure how to erase, so I won't. Okay, now look at our points. I've got this point that I plotted, this point, and they all lie in a straight line. So to make this graph, I'm just going to connect those dots. Now notice it's not perfect. It's not perfect at all. I don't have a ruler, but you probably can use a ruler on your papers and get a little bit better. But this is a straight line. Let's talk about one thing before we go on, and that's right here. Let's talk about finding the x and y intercepts. Now, you can probably guess what x and y intercepts are. This point right here is your y-intercept. It's where your graph hits the y-axis, and this point down here is your x-intercept. Okay, and you'll very often be asked for the exact coordinates of those points. I can sort of guess. I mean, it looks like it's at 6, and it looks like it's maybe at 3, but you need to know exactly. And to do that, here's what you do. To find the x-intercept, to find the x-intercept, in your t-chart, put a 0 in for y and solve. So I go to my equation, I put a 0 in for y and solve for x. So I'll do that. So if I have y I'm putting a 0 in for y, aren't I? Oh, no. Okay, sorry about that. I'm back. Okay, I'm putting a 0 in for y in my original equation. So I have 0 equals negative 2x plus 5. So let's see, I'll subtract 5 from both sides, so I'll have negative 5 equals negative 2x. Divide both sides by negative 2, so I get 5 halves equals x. So 5 halves. So it turns out this point right here, which I thought might be at 3, is actually at 5 halves, which is 2.5. So that is the x-intercept. Now we want to find the y-intercept. It looks like it's up at 6, but I'm not sure. So to find the y-intercept, we put a 0 in for x. So if I put a 0 in for x, back in the original equation, I have, running out of room right here, but y equals negative 2 times 0 plus 5. So that's just 5. So it looks like my drawing was a little bit off. This was supposed to be at 5, but I'm not surprised my drawing's a little bit off. If you look, I didn't quite even make it through the points. But now I know those exact coordinates. My x-intercept is 5 halves comma 0. My y-intercept is 0, 5. So I'm able to find those intercepts like it asked. Okay, let's do one more, and then I will let you do a few homework problems. So here is 2 equations that we want to try to graph, again using t-charts. So I'm going to make a t-chart for this one. Now these don't graph to be straight lines, it turns out. So to make a t-chart, I'm going to pick my favorite values of x, and I'm going to pick, let's say, 2. I'm going to pick 0, and I'm going to pick -2. Maybe that will be enough points, and maybe it won't. Maybe I'll have to come back and plot a few more points, but I'm going to start with those 2, or 3. Okay, so when x is 2, I'm putting this into my original equation. Okay, so if x is 2, this is 2 squared, so -4 plus 1, so y would be -3, right? If x is 0, so this term goes away if this is, and I just get 1. So 0, 1. Oopsie. And if x is -2, -2 squared is 4, and then so I have -4 plus 1, so I have -3. So let me plot those 3 points. 2 comma -3 is right here. 0 comma 1 is right here. -2 comma -3 is right here. Right now it looks like it might be like an upside down V or something. I'm going to try a couple more points. I'm going to try 1 and -1. Okay, so if x is 1, I have 1 squared, so I have -1 plus, I get 0, right? So 1 comma 0. Oh, that side's kind of curvy now. It looks like this isn't a straight line. It's not a V. It's got a little curve to it, doesn't it? Okay, and if x is -1, -1 squared is 1, but the -1 plus 1 is 0, so I get 0 as well. So if I plot a few points, what I'm going to end up with is the shape of this graph is an upside down parabola. Be careful when you draw parabolas. A couple little things about it. First of all, this is not a V here. This is rounded, almost like, you know, the top of a bowl, if a bowl was upside down. That's not very good. What's curvy like that? I don't know. Anyway, there's no point here. Make sure it's curvy. The other thing is that parabolas get wider and wider and wider, wider and wider. They never actually, I don't draw them like this, where they like coming back in. Make sure that they are getting wider and wider and wider. That's kind of more the shape of a parabola. Okay, so there's that one. Let's try this second one over here, this absolute value one. So again, I'm going to make a t-chart. It looks like a T, by the way, in case you wondered why it's called a t-chart. I'm going to fill in my favorite values of x. I'm going to pick 2, 0, and -2, and see what I get for y. Okay, so if x is 2, 3 times 2 is 6, plus 1 is 7, and if I take the absolute value of 7, I get 7. So 2, 7 is a point on this graph. Okay, if x is 0, 3 times 0 is 0, plus 1, so I get 1, right? 0, comma 1. Okay, if x is -2, 3 times -2 is -6, plus 1 is -5. Take the absolute value of -5, and I get 5. So -2, comma 5. Okay. I think I need to plot a few more points. That I can't really tell what the graph looks like. Let's try -1. If x is -1, 3 times -1 is -3, plus 1 is -2. Take the absolute value, and so it's 2, -1, comma 2. Okay. Now, this point you probably wouldn't have thought to try, but try -1/3, just because I said to. Okay, if x is -1/3, 3 times -1/3 is -1, plus 1 is 0, absolute value is 0. Oopsie. So 0. So -1/3, comma 0. It turns out the shape of this graph is, did I plot my 2, 7 correctly? 2, 7, and, oh, I know what I didn't plot correctly. I've got a point that's off right there. It's not going to let me erase it, is it? This point here should be at -2, comma 7, and I didn't do it at -2. I did it at -3. I knew that looked weird. -2, comma 7 is, I'm sorry, -2, comma 5 is actually here. There we go. Now I got some symmetry to my graph. Okay, absolute values turn out to be these. And that V, the vertex, I'm not real great at drawing on my iPad, but the vertex should actually be at negative 1/3, comma 0. This is the vertex of the V. Okay, which is the x-intercept, you can tell. Okay, so see if you can find the x and the y-intercepts too. Remember, you find the x-intercept by putting a 0 in for y. You find the y-intercept by putting a 0 in for x. Okay, I'm going to let you do a couple problems now.